Hello students. Today we are going to be talking about protons, neutrons, and electrons and how they're arranged within an atom. And that is what is known as the atomic structure. It's the structure of an atom, it's how the atom is built and put together. So within an atom there are subatomic particles. Sub, under, atomic, so under the category of the atom, these are the particles within the atom. They are protons, neutrons, and electrons. First of all, the symbol for a proton is P+. That's because the charge on a proton is positive 1. This is a plus sign, not a T. A neutron has 0 charge, therefore the symbol is N0. And an electron has a negative charge, and therefore the symbol is E negative. Protons and neutrons are both located in the nucleus of the atom, which is the center. And all the heavy particles are in the nucleus. Protons and neutrons each weigh 1 atomic mass unit. An atomic mass unit is a unit that is used for protons and neutrons because it made so much more sense than trying to tell the mass of a proton in grams. That would be 0.0000000, 20-something zeros, and finally a number. So that really didn't even make sense, it was so tiny. So it made a lot more sense to say, oh, a proton weighs 1 atomic mass unit, and that just made it a lot easier. Electrons are little lightweight things that weigh almost nothing. That's approximately equal to 0 atomic mass units. I think technically it's 1/1840th of an atomic mass unit, but yeah, approximately 0 is all you need to know. Now where the electrons are found is on the outside. So protons and neutrons are in the nucleus, and electrons are in the energy levels outside the nucleus. 2 electrons are in the first energy level, 8 electrons are in that second energy level, and remember it's 3D, so I'm doing this, but it's actually doing this. So first energy level, second energy level, third. Within these energy levels are also called orbitals or electron clouds. So first of all, let's take a look at the atomic number of an element. It is the number of protons in an atom. This is the most important number on the periodic table, and it's the most important number about an atom. It's how you identify an element. The number of protons makes it be that particular element. If it has a different number of protons, it's a different element. It is the whole number on the periodic table. So, for example, hydrogen is atomic number 1. It has 1 proton. Helium has 2 protons. Lithium 3, beryllium 4, you get the idea. The mass number is the mass of that particular atom, and it is the number of the 2 heavy particles. That makes sense. The mass should be made up of the ones that weigh enough to count. And so if you add together your protons and your neutrons, that will give you your mass number. This number is not on the periodic table because atoms can have different numbers of neutrons. Even the same atom can have different number of neutrons. And so that makes it, you would have to put several different mass numbers on there. Next, isotopes are these same elements, the same element, but with a different number of neutrons. So they have to have the same number of protons, that's what makes it the same element, but a different number of neutrons makes it a different isotope. And that's what gives it the different mass numbers. All right, so it would be nice to have a memory trick for knowing how to remember all this stuff. Well, first of all, atomic number and mass number are both whole numbers. So right now, we are not dealing with the decimal number on the periodic table. We'll deal with that later. Right now, we're only dealing with the atomic number, which is the whole number. And like I said, we are dealing with the mass number, which is not on the periodic table. All right, so when you're dealing with a neutral atom, not an ion, no charges, just a plain atom, one memory trick is APE. A stands for the atomic number, P for protons, and E for electrons. And it turns out in a neutral atom, The atomic number is the same thing as the number of protons, and it's the same thing as the number of electrons, which makes sense. The positive protons and the negative electrons, if they're equal, they cancel each other out, and that's what makes it neutral. Now, the other memory trick is man. The mass number minus the atomic number will tell you how many neutrons. It's like, wait a minute, that's confusing. Well, the mass number is the protons plus the neutrons. The atomic number is the same as the number of protons. And if you take your protons and your neutrons and subtract out your protons, you get your neutrons. All right, so let's look at how we will do some of the problems and some of these questions that you can be asked. First of all, let's take a look at the isotope carbon-13. Carbon actually has at least 3 isotopes: carbon-14, carbon-13, and carbon-12. And carbon-12 is the most common one. So let's see what all this means. First of all, find the element carbon on the periodic table. Carbon's atomic number is 6. And remember, the atomic number is equal to the number of protons, which is equal to the number of electrons. So if there's atomic number is 6, you also have 6 electrons and 6 protons. Next, let's look at the neutrons. Well, if we could take the mass number minus the atomic number, we could get our neutrons, but that's not happening, so we need some more information. Well, what's this 13 right here? It turns out this number is actually the mass number. Aha! Now we can subtract. Mass number of 13 minus atomic number of 6 gives us 7 neutrons. Now we're ready for the symbol. Back on the periodic table, the symbol for carbon is a capital C. Remember, the first letter is always capitalized. Put this over to the right of the box and leave yourself some room on the left for some numbers. This man memory trick will also help you remember that the mass number goes over the atomic number, and it's ready to subtract. So we have a mass number of 13 that goes on top, and an atomic number of 6 which goes on bottom. This is not division. Don't put a dividing line between them. This is actually just saying this is the mass number, this is the atomic number. Now you figure out carbon-12. Pause this video and practice filling in the second line here. If you know what you're doing, you may fast forward through this next line and jump ahead to the next problem. So carbon-12, the 12 is the mass number. They give that to you because it's not on the periodic table. Carbon is atomic number 6. Carbon is always atomic number 6 because that's how you know what the element is. That is the number of protons and the number of electrons. Now we're ready to find the mass number. The number of neutrons. The mass number minus the atomic number gives you your neutrons. So 12 minus 6 gives you 6 neutrons. Now write the symbol. C for carbon. The mass number goes on top, that's 12, and the atomic number goes on bottom, that's 6. All right, for the next problem, they've given you a backwards question. We have a mass number of 37, an atomic number of 17. Well, now what? Well, the atomic number is what you can look up on the periodic table to figure out which element you have. So we're going to look up atomic number 17, and there it is, and that is chlorine. The first letter is always capital, the second letter is always lowercase. That's how you know this is a lowercase l rather than a capital I, which is a little bit confusing. This one, the only letter is an I, and we know it must be a capital I because the first or the only letter is always capitalized. So chlorine, C-L, and the spelling, C-H-L-O-R-I-N-E, and the number that goes after it is always the mass number. So this is chlorine 37. Now, the mass number of 37 goes over the atomic number of 17. Also, mass number minus atomic number will give you neutrons. So that gives you 20 neutrons. And finally, the atomic number, the proton, and the electrons are all the same. So if the atomic number is 17, so are the electrons and the protons. If you know what you're doing, stop the video and go ahead and finish up this worksheet. If you need more help, continue watching. So this time we have the protons and the neutrons, which is a little confusing. So notice that the atomic number, the protons and the electrons are the same. Oh, okay, so if we have 17 protons, we have 17 electrons and an atomic number of 17. Now we look up element 17. Oh, hey, wait a minute. Atomic number 17, it's got to be the same element. But if you forget, just look up 17 and that must be chlorine. So Cl, and this is chlorine. We don't have a mass number yet, so let's wait just a bit. And we have an atomic number to go on the bottom, but not the mass number. So now what? Well, subtraction is a little bit confusing. I mean, yes, we could say what number minus 17 gives us 18. That's going to confuse me to death. So when this is confusing, try this formula. It's the same thing, but in a different format. The protons plus the neutrons add up to the mass number. Ah, so protons plus neutrons add up to the mass number. That must be 35. Now, this is chlorine 35, and 35 over 17 Cl is the symbol for chlorine 35. If you need more help with this, please call me or email me, and I will be glad to help you.